this graph would become narrower. It would become more like that. Okay. If we have f of a times x, this horizontally stretches it. So this x value would kind of get larger. So, okay. It would, okay, f of ax would change the horizontal stretching. It would make it narrower because now we have ax is now equal to the x value. So it makes that value at ax become the value of f of x. So f of ax is over here. Then we would now make it equal to the point like f of x. And so it would just make it narrower. It would actually be on the same y value. So it would shift it like that. Okay. The vertically stretching, it's still kind of making it narrower, but I just mean the y values get larger. So if we have a point like over here, the y value, we would have a times this y value. So it would become the point like up here. So it would still touch that place. Okay, and then if we have f of x plus a, this means it's just shifting the function up by a. So it is a vertically shifting. If the a is negative, of course, it's going to go down. But if it's shifting up, let's say a positive direction, it would shift it like that. Okay, and then we have an order of how we do these things. So if we have f of x maps to a times f of b of x plus c plus c, that's all in the function, plus d, we first narrow it by a factor of b first, and then we shift it to the left by c, because multiplication first always happens before addition, but since it's all inside of the function, you do that function first. And then you stretch it vertically by a, and then you shift up by d. Okay, so we're trying an example now, I believe, and try to draw this map yourself. We're mapping f of x equals root x to 2 times f of x plus 1 plus 1. So try to draw it, and you can type to me in the chat like what shifting you did or what kind of stretching you did in order to get your answer. I'll give you 2 minutes. Okay, so you should have gotten this graph. So you shift to the left by 1 because we first do what's inside the function first, and then we vertically multiply it by 2, and then we shift it upwards by 1. Okay. Actually, I think I said a lie back there. Okay, go back. We did not have an example for this, but if we have bx plus c, we don't actually narrow it by a factor of b first and then shift it to the left by c. We actually first kind of factor out this b plus b times x plus c over b. Okay, that should have been what we should have done. Okay, so we shift it to the left by c over b, and then since we're multiplying this whole thing by b, we then vertically stretch it. I meant horizontally stretch it by b. When I'm saying stretching it, I mean narrowing it. Sorry for the wording, because when you're doing it horizontally, it always narrows. Okay. So now we're moving on to the problem solving and data analysis part. This section, I'm not going to cover every single thing because there are many topics, but I saw that most of you requested for things like standard deviation and box plots. So I will first go over the main topics of this section, and I will provide you the basic formulas that you need to know, and we can continue with just the main parts that I think more people need to know about. Okay, so first of all, they test on ratios, rates, and proportions. I think a lot of people already know this, like fractions and ratios. Okay, we also talk about percents. So the main thing you need to know is just if you do a decimal, you multiply by 100 to get the percent value. If you have that percent value, you divide it by 100 to get the decimal value. And if you have a decrease, a 3% decrease, you would have 0.97. So you get it by 1 minus 0.03 to get that it's 0.97 times the original amount. That's the remaining part. Okay. There's also a lot of conversion between units, and then a lot of tables that you just interpret and try to come up with the answer or make inferences based on the table. They give you scatter plots. So these are the main scatter plots that I think you should kind of know. So there are 4 different types. The first one is that there is a strong linear positive correlation between the x value and the y value. The second one is that there is a moderate, so it's not as tightly packed as the first one. So it's more moderate and it has a negative correlation. It's going down. So an increase in this x value results in a decrease in the y value. And this is also linear. This is no relationship. We can't really tell that there is a specific correlation. And then there's also a non-linear correlation. So it can be in the form of a parabola. So the y value increases as the x value increases for some time, and then it starts to decrease later. And since it's all very close to this parabola shape, we say that this is a very strong nonlinear relationship. Okay, we also have key features of graphs. So we have direct proportion. This is a straight line going up. We also have inversely proportionate. So that means that x times y would be a constant. directly proportionate would be x over y is a constant. So inverse proportion would have an exponential graph. Okay, and then we also have inferences based on the data, and we're going to go over center, spread, and shape of distributions. So that's also part of data analysis, and we also have data collection and conclusions. For the ratios, rates, and proportions, I think one thing that they're going to talk a lot about would be the relationship between distance, speed, and time. So just remember, distance is the speed times the time. Okay. So now we're moving on to the center, spread, and shape distributions. The three centers we talk about are mode, median, and range. Mode, median, and mean, and then range is a separate thing. I think we all know what range is. Common graphs are histograms and box plots, and we'll go over both of those. And variance, standard deviation, and like outliers, they also help determine spread. Remember the question in the beginning of class? We talked about outlier and how it affects the mean of this problem. And then there would also be margin of error problems, but I don't think we're going to have time to touch on that today. Okay, so center, mean, median, and mode. So the mean is the basic average. You add up all the values and then you divide it by the total number of things there are, the total number of values there are. So if we have 2, 2, 3, 5, 5, 7, and 8, the mean would be the sum of this, which is 32, divided by the 7 values. So that would just get us 4.57. If we have the median, we have that it is the middle value. Okay, so we had to list this from least to greatest, and we find the middle value. An easy way to find this is if you count the number, and if it is odd, we can add 1 to that number and we divide by 2. So if it's 9, we add 1 to 9 to get 10, and the middle number would be the number at the 5th spot, because 10 divided by 2 is 5. If it is even, you just divide the whole thing by 2 and take the number between that last number that you just got and that number plus 1. So if you have 8 numbers in total, you would have that the median is the average of the 4th and the 5th number, because 8 divided by 2 is 4, and then the number, the 1 plus 4 is 5. So we take the 4th and the 5th number and their average. Okay, and then mode is just the most frequent value. So we just count how many there may appear in a sequence, and you can also have more than one mode. So in this case, the modes would be 2 and 5. And then the range is just the highest value subtracting the lowest value, and that's just the range. Okay, so now we have a histogram. A histogram is basically what we kind of call a bar graph. So it's the frequency of the numerical data using these rectangles. So if we have the number of goals scored, we see that 8 people, well, in 8 games, there was 1 goal scored. In 9 of these games, there were 2 goals scored. So the total number of goals scored would just be this value on the y-axis times this value on the x-axis, and then we add up all of the areas of these rectangles, basically. And that is the total number of goals scored. The total number of games there are would just be the sum of the numbers on the y-axis over here. So it would be 8, 9, 6, 3, 2, because that is just the number of games that there are. That's the only thing that counts it. Okay, and so we already covered that. And now we have some practice problems. So I'll give you 2 minutes. Okay, so 2 minutes has passed. This is basically what we were talking about before. The mean, we are trying to find it. And we have that the total number of seeds of the apples is just the areas of the rectangles all added together. So we have that the total number of seeds, we do it, it's 73. And then there are exactly 12 apples. Okay, it's right there in the title. So we just do 73 divided by 12, and it's closest to 6, so that would get us C. Okay, our next example, you can try it. Okay, so this one should have been faster, so I gave you less time. So for this one, it's just interpreting the graph. So we have the number sold at 2008 and the number sold in 2011. So over here, it's 160 million, and over here it's 100 million. So we're trying to find the fraction from 2008 over the number sold in 2011. So we have 100 million divided by 160 million. And the millions basically cancel out. So this would just get us 5/8. So you could have done it by writing out 100 million and 160 million, or you could have just canceled out the millions and have just done that. Okay, so we are now talking about box and whisker plots. So why are these important? Well, this graph or this plot has the extreme values at the very ends, And then there are different quartiles. So each of these quartiles represents 25% of the data. So 25% lie between the most extreme, the smallest value in the first quartile, and then 25% lie between those two and those two and those two. So this length of the box represents the interquartile range. And so it is the range between the third quartile and the first quartile. The second quartile is the median. And then these horizontal lines extending outwards are kind of like whiskers, and that's why it's called box and whisker plot. And these are the lowest and upper fourths of the data. And these bullets are extreme values. So, example, we have to draw this box and whisker plot for 3, 7, 9, 14, 16, 19, 19, 25, and 28. So we first have already ordered the data from least to greatest, but if you haven't already, or if it isn't given already, then you have to do that because we are finding the median. And in order to find the median, you need to have the data ordered. So in this case, there are, I believe, 9 of these values, and so we take the fifth value, so that is 16. That is the median. That is quartile 2. Now we look at the lower quartile. You do not include the median if it is already graphed. So now we look at 3, 7, 9, and 14 for the lower quartile. This is quartile 1. It would be between 7 and 9. So the average of that is 8. Then we look at the upper one. So this would be the average between 19 and 25, and that would be 22. Okay. So then we have that this is 8 and this is 22, and the interquartile range is just the difference between 22 and 8, which is 14. And then for outliers, how you check it is to make sure that there are, if it is an outlier, it is below 1.5 interquartile ranges less, below than quartile 1. So this point here. Or it is greater than 1.5 interquartile ranges, greater than quartile 3. So an example for this one, we have 8, which is at quartile 1, minus 1.5 times 14, because that is our interquartile range. That's equal to negative 13. But we don't have any points that are outliers like that, that are less than 3 or less than negative 13. And then we do that on the other side. So we have that this is 22, and so we add 1.5 times 14. That would get us 43, but there are also no numbers that are greater than that. So there are no numbers that are greater than or equal to. Okay, so there are no outliers. Okay, so number 2, after we have done all of that, to draw this, we first have a number line. Make sure you have included the extremes, and then you complete this box and whisker plot. So between quartile 1 and quartile 3, draw a box, and then make a line through the median, and then the other ones go to the extreme values. Okay, so I have some practice. We are running a little slow on time, so I'll give you a minute for this one. You can give me quartile 1, quartile 2, quartile 3, and the range, and the interquartile range. Okay, I know I probably did not give you enough time for this, but I will just continue from here. First, we find the median value. Okay, so the median value, we see that in this part, there are 12 values. So there are 12 values. That means we look at the average of the 6th and the 7th value, which is 11 and 12. So we have that quartile 2 is 11.5. Okay? And then because this is not an odd number of points, our median is in the middle right here. We take these 6 numbers and find the median of that for the quartile 1. So this would be right here, 7.5. And in this one, we take the average of 14 and 15. So this is 14.5. And so if we have our box over here, our interquartile range would be the difference between 14.5 and 7.5. So that's just 7. And our total range is the difference between 23 and 2, and that is 21. Okay, and if you drew the plot, it should have looked like that. Okay, for this one, I will also give you a minute, and you can try it. Okay, perfect. So we first always take the median value. So the median value, there are many more points over here. So our median value would be 50. I think it is, okay. Okay, so there are 16 values or 15 values, I think. So there are 15 values. Yeah. So we take the 8th value, and the 8th value is this 50 right here. So this is our median. We do not include it in our calculation of quartile 1 and quartile 3. So then we take the median between 5 and this 50 value. So that would be 46 right here. And then we take the median between this 50 and the 102 right here. So that would be 56. Okay, so now we basically have it. Our interquartile range is 10. So our outlier has to be greater than or equal to 1.5 times 10 below 46, or 1.5 times 10 above 56. So that means that it would be less than 31, less than or equal to 31, or greater than or equal to 71. And so our outliers would be 5, 75, and 102. And so you always have to add in these dots, because we just consider the points that are not outliers. Okay, so you add in the outliers, but don't draw the whiskers out to the most extreme values. Okay. So now we're learning about negatively skewed and positively skewed. Okay, so it's much easier to see it with a box plot. So a box plot, since it splits the data into the 4 areas with 25% each, you can easily tell if it is positively skewed or negatively skewed. So if it is positively skewed, the majority of the data lies on the right side of the graph. Okay? And then you can see it by like a bigger box or a bigger whisker. And then for a negatively skewed one, you see if it is if more of the data is on the left. Okay, this is more negative. So this is also known as a right skew, and this is also known as a left skew. If it is a histogram, it's basically kind of the same thing. If there is more of the data on this side of the graph, then that means that it is negatively skewed, left skew. If more of the data is on the right side of the graph, then that means it is positively skewed. It might be a little confusing, so we will try an example. Okay, so for this one, we do the box and whisker plot. You can send me your answers and then tell me how is this data skewed. Okay, perfect. I did not give you a lot of time on this, but we are running a little short on time, so I will continue. Okay, so the extremes of this data you can find by the very end points, that's 39 and 30. And then we have that the range is 39 minus 30, which is 9. And then our median, it's the line in the box, so that's 35. And then our interquartile range is between Q3 and Q1, so it's 36 minus 32, which is 4. And it is skewed to the left because more of the data is on the left. So that means it is a negative skew. Okay, so now we'll be talking about variance and standard deviation. Variance is actually not tested on the SAT, but it is very much related to standard deviation. So I will also talk about it here. So variance is the average squared deviations from the mean. Deviations just means the difference between the data and the mean. That is like the difference. And standard deviation is the square root of the variance. So it would always be denoted as s of x, and if it's the variance, it would be denoted as s squared x. Okay, so the difference between the variance and the standard deviation is that the standard deviation is expressed in the same units as the original value. So if it was minutes or meters in the original value, the standard deviation of it would also be in minutes or meters. And then it is basically a measure of how the spread of the data. So if they are closer to the mean, that means that it is very close to the mean. The spread is very low. And then if the number is high, then there is a greater spread of the data. And so that means they are spread out over a wider range of values. And if they are all the same point, the standard deviation is 0. Okay, so we have that. Okay, so now you can try the practice. I'll give you a minute. Okay, so for these two questions, you can basically just eyeball the answers because you can already see like the spread of the data. If they are closer to the mean, you can kind of see like data set 1, it has values from 1 all the way to 8. And then in data set 2, it has values from 2 to 5. There's less of a variation. And this is already all ordered for me. And then in data set 3, there's only 3s and 4s. So the set with the largest standard deviation would be data set 1. Okay. And then the set with the smallest standard deviation is data set 3. Okay. And yes. Okay, so now we are moving on to our additional topics. So this is mostly just geometry, and I will just speed through these. If you have questions, you can ask me after class, but I will try to finish all of this. Okay, so first of all, SAT tests most basic geometry. So remember, SOHCAHTOA. So sine is equal to opposite over the hypotenuse. So if we have sine of A, it's this opposite side over the hypotenuse. And then we have the cosine is the adjacent. So cosine of A is the adjacent over the hypotenuse. And then TOA, the tangent is the opposite over the adjacent. So tangent of A is the opposite over the adjacent. Okay. And then, so we have these 3 forms over here. And then there are these co-functions. So that means that it's basically saying that if there's sine A and cosine B, we know that sine of A is equal to cosine of B because sine of A is BC over 8B, and so is cosine of B because it's the adjacent over the hypotenuse. So the A plus the B is equal to 90 degrees because this is in a right triangle. Okay. If this angle A plus angle B is 90, we know that sine of A equals cosine of B, and same if it's the reverse part. Okay. If those two are equal to 90, we also know these other functions. These other functions are, yes, I will just call them functions. Okay, these other functions are not really tested on the SAT as much as sine and cosine, but just know that cosecant is 1 over sine of A, and secant is 1 over cosine of B. Okay? These are not the same as the inverse functions. So those are arc sine, which takes a ratio of the sides to convert it to an angle. Okay, and we also have tan of A equals cotangent of B. So that's just 1 over tan of B. And those are equal. Okay. So now, in this figure, we have that the length of this BC is 15, and the value of cosine of angle BAC is 0.8. So what is the value of BD? And if you can find the answer, you can send it to me in the chat. Okay, I will go over these real quick. So I know that this one's answer was already on the slide, but this first one wasn't. So if we know that cosine of BAC is 0.8, we use our cofunction. So we know that sine of angle C would then be 0.8. Okay? So sine of angle C is also just BD over BC. So BD over BC is 0.8, and we just make it so that 0.8 times 15 is BD, and that equals 12. Okay, for our next one, we still use our cofunction, and so that is just making us say that the 3x plus 5 plus 2x minus 15 must equal the 90 degrees, because that is how we define our cofunction. So that is 5x equals 100 degrees, so x is 20 degrees. Okay, we also need to know some Pythagorean trig identities. Okay, so the most common one, sine squared plus cosine squared, is 1. That is very important. And then we also have some other ones, so like tan squared plus 1 equals secant squared. And we also have cotangent squared plus 1 is cosecant squared. But those are not really tested. Okay, so just know the main one. Sine squared plus cosine squared is 1, no matter what the angle is. The angle just has to be the same. Okay, now we look at radians. There are 2 pi radians in a circle. So this is because the circumference is 2 pi times the radius. So there are 2 pi radians. And then that means that 360 degrees, we're going to say this is equal to 2 pi radians. So to convert from these radians to degrees, we have that radians times 180 degrees over pi is the number of degrees that you're trying to calculate. This is because 100 degrees is the same as pi. And to convert from degrees to radians, we have the degrees times pi over 180 degrees is the number of radians there are. Okay, so now we have angles and arcs and sectors. So we know that the length of an arc over the circumference would be the same as the area of that sector over the area of the circle times, that's also equal to the number of angles there are in an arc over 360 degrees, or the number of radians there are in the arc over 2 pi, because those are all the same. Okay, so the circle has a circumference of 36, so we're trying to find the length of AC. You can send me the answer if you have it. And it should have been pretty easy because this is 90 degrees. So 90 over 360 is 1 over 4. So 1 over 4 times 36, because we know that our arc over our circumference is equal to 1/4. That means that our arc length would just be 9. Okay, and for radians, we have that the length of this minor arc is also equal to the radians times the theta. This theta is going to be the number of degrees. Well, this is not in degrees. This is the number of radians that are in this arc. So that is the length of this minor arc. The area of the sector is also just 1/2 times this radius squared times the theta in radians. Okay? So those are also some important formulas, but you can also derive it by just knowing the conversion between degrees and radians. Okay. So now we have some more practice. I can go through this quickly, or we can move on to other things. Okay, I'll just go through this slide quickly and I will try to get through as much as I can. Okay, so these points lie on a circle with radius 1, and we know that the arc has a length of pi over 3. So we need to find the fraction of the circumference of the circle that this this arc AB is. So since this is a circle with radius 1, there is 2 pi radians in the circumference of the circle. So pi over 3 over 2 pi gets us 1 over 6. Okay, for the next one, we have a point A that is the center, and we have that this arc is 2 over 5 over the circumference of the circle. So we're trying to find the value of x. Well, we know that the length of this arc over the circumference is the same as the x over the 360 degrees. That was one of our formulas. So we just find that and get that it is equal to 144. Okay, I will skip this practice. Okay, so now for circles, here are just some formulas you need to remember. These are called inscribed angles, right here, and they are 1/2 of the normal angle that you have here. Okay, if we have tangents, these are always 90 degrees, and the sum of the angle over here and the sum and that angle over there is always 180. If this is a diameter of the circle, this is 90 degrees. If we have a circle on the bottom here, we have that this alpha equals the beta because these are both inscribed angles of the same arc. And now we also have power of the point. So this is just saying that this length times this length is equal to this length times this length. And you can derive it by similar triangles if you draw it like this, since we already know that that angle equals that angle and that angle equals that angle. Okay. And then our final one over here is that alpha plus the beta equals 180. This is called a cyclic quadrilateral. So it is inscribed in a circle. You can also know that this alpha equals the gamma on the outside. Okay. So we have more practice. I will post the slides so you can do this yourself. But we also have complex numbers. We are over time. So if you want to leave, you can leave. But I will go through this slide and I think I will finish after that. Okay, so for complex numbers, these are just numbers that have a real part and an imaginary part. So this real part would be denoted as A, that's what I usually denote it as, and the imaginary part would be B times I. So that I is square root of -1, okay? So two complex numbers are equal if and only if the real and imaginary parts are equal. So if we have A plus BI equals C plus DI, we know that A equals C and B equals D. We also know that the distance from the origin, this is also called the magnitude, is square root of A squared plus B squared. That is the distance from the origin. And this is an interesting fact. If we multiply it by the conjugate, remember the conjugate again is that plus is switched to a minus. This would just get A squared plus B squared. So that is an interesting fact. Okay, and the magnitude is the length of this line. Okay, so we have more examples of complex numbers. For this one, just know I to the fourth is equal to 1. And this one, convert it to complex numbers, an imaginary number first. Because if you don't, you can get square root of 36 and you can get 6. But the answer is -6 because this is actually I times square root of 12 and this is I times square root of 3. So this would actually be -6. Okay. And then I'm pretty sure we can do data interpretation and conclusions from graphs. So I think it is fine and I will skip over these slides. Okay, so now these are just solids and their formulas. Oopsies. Okay, so surface area, just know that the volume, surface area of a cube or just a rectangular solid, it is the length times the width plus the width times the height plus the height times the length, and this whole thing has to be multiplied by 2 because there's 2 on both sides. And then the volume is the x times the y times the z, and the length of the diagonal from one side to the very opposite corner is square root of x squared plus y squared plus z squared. For a cylinder, the surface area is the surface area of the top circle plus the bottom circle plus this length times the circumference of this. Because if we roll it out, we basically just get a rectangle. And this side length is 2 pi r because that is the circumference of the circle. Okay? And we have to add in the 2 circles at the top and the bottom. And then for the cone, we have that the surface area is equal to this bottom base circle plus, if we roll out the cone, it's always going to be a sector of a circle. So we find the surface area of the sector, which is pi times r times this length, which is actually right here. This is basically the radius if we're rolling it out. The lateral area is basically this thing. We don't include the bottom circle. And the volume is 1/3 of pi r squared times the height. But these volume formulas are actually given on the SAT and the area formulas. These are special right triangles, but they give them to you. So the surface area ones you probably need to remember, but the volume ones you don't need to remember as much. Okay, and I have some examples. Okay, so thank you for coming. We are ending class now. So a few notes before you go. So the slides will be posted, so if you want, you can look through it. There are also videos that you can watch. And if you have any questions, you can ask me after, or you can sign up for tomorrow's session where I will kind of be going over specific topics. If people have questions or specific topics they want to go over, they can ask me then. I will post the Google form after. And if many people sign up, I will try it with small groups. Oh, the Google Drive folder, it should have all been shared with you, but I will see if I can show you. You can go if you want. Okay. This folder should have been shared with you when you signed up. So it has a bunch of practice tests that you can go through. And then I have the slides posted here. So yesterday's slides are in this folder. And then you also have many books for practice that you can go through over here. And you can read through the study guides for each of the sections on the SAT. So there you go. I will post the form to sign up for tomorrow later today. Okay, bye. See you.
Wait, have you shared the slides?
Yes, I can share it. Let me see. I don't know if you can access it though, because I think it has to be shared. If you can give me the email in the chat, I think.
I got it.
Oh, okay.
Thank you.
Okay. Bye bye. Do you have any questions? If not, I will leave. Sorry. Okay, I will leave. Bye bye.